Hi everyone. Today we're going to talk about tides and why we have tides here on Earth. So we'll look at the tidal cycle and learn how that is related to the orientation of the sun, the moon, and the Earth. And we'll explain the difference between spring tide and neap tide and how we get either spring tide or neap tide. So tides are caused by the gravitational attraction between the Earth and the moon, and between the Earth and the sun. So the moon pulls on Earth's surface, which creates a stretching effect, which means the oceans on the side closest to the moon bulge. They kind of stretch out like this. So here's the moon, here's the Earth rotating. We're looking at the Earth from the top-down North Pole. And the oceans on Earth stretch into this bulge. So we get this bulging effect. So there's two bulges on either side of the Earth in alignment with the moon. So we see that drawn here as well. Here are the arrows of gravitational force. So the strongest force is on the side that's closest to the moon. Everywhere else is pulling towards the Earth. We end up with this stretching effect. So the net effect on Earth is this stretching. So what stretches easiest on Earth is liquid water. So we get bulging of liquid water towards our moon. So here is another diagram where we show that bulge. So you've heard me talk quite a bit in this class. So I found a great video and I thought I would let a famous scientist explain this topic because I think he does a really good job in this video. So I'm only going to show the first 4 or so minutes of this video. If you want to watch the rest of it, the link is here in the slide.
From my personal experience, anything you want to know, this man right here, especially when it comes to science, has the answer. Okay? So,
no, I have an answer. Whether or not it's the answer, that's to be determined.
Please, you're ruining what I believe in. Okay?
I want to dismantle your belief system.
Exactly. My whole world is crumbling. I need to believe in you, man. All right?
Tides are widely misunderstood.
Okay.
All right? I will say, the next thing I say may be mind-blowing to you.
Okay.
Okay? The tide doesn't actually come in and out.
What?
What happens is there is a bulge of water, 2 of them, on opposite sides of the Earth, caused by the sun and the moon. And Earth turns inside that bulge.
Mm-hmm.
So when we say the water rises and falls tidally, what's happening is we are rotating into the bulge and then out of the bulge.
So the bulge is already there.
It's already there.
And all we kind of do is pass through the bulge.
Pass through, and the water gets high and it gets low. So we're stuck with language from our own perspective rather than language of what's actually happening.
Mm-hmm.
It's simpler that way to say the water goes in and out. It's simpler to say the sun set rather than Earth rotated such that our angle of view on the stationary sun fell below our local horizon.
Right. Sunset is far more poetic.
Yeah, you go to the sunset tables, to look this up.
Yeah, because you can't say to a girl, hey, how'd you like to go and watch the angular momentum of the Earth cause the sun to disappear behind a horizon?
Hello, where'd you go? Let's look at just the Earth and the moon for the moment.
Okay. Which
So
many people think the moon is what causes it.
No, the moon is 2/3 of the tides.
Okay.
The sun is 2/3, 3/4. Depends on the distance. The sun has its own tides on the Earth.
Oh, snap.
Wait, in fact, the tides that the moon raises on Earth are the same no matter the phase.
Okay. No matter the phase of the moon, which there are some people believe that when you have a full moon, what you have is a higher tide because you have a fuller moon.
You do have a higher tide.
Oh, snap.
But the tide that the moon raises on the Earth is basically the same no matter its phase.
No matter its phase.
What happens at full moon is that the sun's tides add to the moon's tides precisely.
Oh, snap. We talking about a tide assist from the sun?
Tide assist.
Oh.
A tide assist. And so that's why...
And that coincides with the full moon.
Coincides with... with the full moon. Because the full moon, you got the moon here,
Right.
Earth, and the sun. Everybody lines up.
That's what it is.
In fact, we have a word for that.
Go ahead.
That has the most number of letters when scripted. Is dip below the line.
Okay.
I know that's a weird record to hold.
Right.
The word is syzygy. So syzygy is when 3 or more objects come into alignment cosmically.
Right.
So you have the moon, the Earth. The moon will have the same tide it would at any time,
Right.
but now it lines up with the sun.
Right.
They add together, you get the highest
tide.
tides at full moon and new moon. So now I ask you, when would you get the lowest tides?
When the sun is not lined up.
Okay. Okay. Let me quantify that. So when the sun is at 90 degrees,
Right.
the sun is pulling this way, and the moon is
Moon's
pulling
pulling
that
that
way,
way.
and the two waves
Right.
basically cancel.
Exactly.
They try to cancel one another. So you have the lowest tide. It's called the neap tide.
The neap?
Neap.
Neap tide.
Neap tide.
See, look at this. It's not the moon. It was the sun all
All the
along.
time. It was the sun all the time.
I see. And you think because,
Wait. So when people say,
Uh-huh.
I feel the extra tidal forces from the moon when it's full,
Right.
it's just bullshit.
Oh,
So just want to clear that up.
Okay.
So I haven't explained tides yet. Let me take 2 minutes to explain that.
holy crap.
Okay.
That was just about the moon and the sun and the fact that the bulge. So that's what we have right
So
now.
watch what happens.
Go ahead, go for it.
So let's just look at Earth and the moon for the moment. The side of the Earth that's closest to the moon feels a stronger gravitational pull of the moon than the side of the Earth that's farthest away. Okay.
Right.
The closer you are to the source of gravity, the stronger is that force.
Right.
Is that force? That's true for everything.
Right.
No
So
matter
the
what.
moon is always exerting a gravitational pull on the Earth.
On the Earth, yes. And there's a difference in the gravitational pull from one side to the other.
Okay.
Because if there's a difference, it means it's pulling this harder than that.
Right.
If you do that, you end up stretching.
Okay.
So the water stretches along the line that the moon's tidal forces are pulling.
Gotcha.
Okay, it's a stretching force.
Right.
All right. And by the way,
We're going to call that Earth Yoga. so yes. And now,
okay.
downward dog.
So it does that for anything. Water happens to be more responsive to this force because it's liquid,
Right.
but it also raises tides on the solid Earth.
Oh.
But you don't see that
Right, you're not
happening.
gonna see that.
You don't know, and it's small, much smaller, and so, but it does it basically for everything. And so that's how you get a tides. That's how you get the tides.
Wow.
And so that bulge is always there, but the sun is messing with it.
Right.
Okay.
Exactly.
So as the moon orbits the Earth, and the tidal bulge sort of
Tidal bulge is
moving with the moon,
Right.
and the sun is like
Exerting its forces
its force
simultaneously.
and it either lines up or it doesn't.
Wow.
Okay. How much brain you got left to get?
I don't know, man. We about this.
Okay, so now watch.
We were only working with this to begin with. Now we down to about this.
Okay, so watch what happens.
Go ahead.
So it turns out we are rotating faster than the time it takes the moon to go around the Earth. Okay? So a day is shorter than a month. Okay? All right. So we are actually, if you, the viewer, are the moon, and you're trying to raise this bulge, okay? I am dragging the bulge ahead of you because I'm rotating faster.
That's right.
Okay? So the bulge is not actually exactly aligned.
No, it's over here.
It's like that way,
And then
at
you're-
that angle.
And you're pulling.
So now watch. So
Go
watch.
ahead.
Watch. So it's because I'm rotating. So now
Right.
watch. So the moon is actually tugging on that bulge, trying to line it back up.
Right.
And it does that against the wishes of our rotation.
Right.
So the tidal bulge, because of the moon, is slowing down the rotation of the Earth.
So are you telling me that?
That's why we have leap seconds.
There you go.
So the tides are not only responsible for what we perceive as water going in and out, it's responsible for the slowing down of the rotation of the Earth. And the Earth has been slowing down ever since the moon has existed. Okay? And we know this because there are mollusks that have certain features in their physical.
So feel free to watch the whole video. It's really interesting. He's awesome. If you want to learn more, but I really like the way that he explained, and I like their graphics. So I will go over quickly what they just talked about. So the tides, like you said, they don't come in and out. The Earth is moving into and out of the tidal bulge. So like this video, you can see that the bulge is there. The Earth is spinning in and out of that bulge, depending on where you're standing. So the high tides are in a line with the moon. The low tides are offset from the moon. So the high tides and low tides caused by the moon are super consistent, both in size or amplitude and in time. So if we had a tide chart based on just the lunar tides or just the tides caused by the moon, it would be super consistent. So we would have high tide, low tide, etc. Very perfectly timed, and they would be exactly the same height. Same high tide, same low tide, same high tide, same low tide, all the time. However, well, we actually get something a little bit more like this, where we have one high tide that's super high, we have a low tide that's kind of high, and then we have a high tide that's kind of low, and then we have a super low tide, and then we have a really high tide again. So they're not as consistent. It's not the same high tide all the time, not the same low tide all the time. It's changing. And that is because of the sun. So like they said in the video, it's the fact that the sun is also pulling on the Earth's surface. So there's also a gravitational attraction between the sun and the Earth. So sometimes the solar tides caused by the sun align with the lunar tides caused by the moon. This is when we have the most extreme tides, the highest high tides, and that is called spring tides. So this is where we have alignment of the sun, the moon, and the Earth. So this also happens when the moon is on the other side of the Earth. So it's as long as they are in alignment, where the two high tides, the solar and the lunar, combine, add together to be super high tides. So here it shows neap tide and spring tide graphed together. So spring tide is when the sun and the moon are in alignment. So at full moon or new moon, where we're going to have the highest high tides and the lowest low tides. Neap tides are where they're not in alignment, so at either of the quarter moons. So we're going to have more muted tides, not as extreme. So the range from high tide to low tide during the neap tide is going to be much smaller than the range from high tide to low tide in spring tide. So when do we have the lowest low tides, the least extreme difference? Here is a diagram showing that, where we have our neap tide and the sun and the moon are out of alignment with the Earth. So this is like what they said in the video, where the tides almost cancel out. So we still have a slight solar tide from the sun, but the majority of our tide, which is about 2/3 or 3/4 of our tide, is caused by the moon. So when the moon is in either the first quarter or the third quarter position, out of alignment with the sun, is where the tides are working in opposition. So the solar tide and the lunar tides are not combined, they're working against each other. It makes our high tides less high and our low tides less low. So they're going to be, it's going to be a much smaller range in high tide to low tide when we have this out of alignment situation where we have what we call neap tides. So here now we see both. So here's spring tide on the top, where we have the teal light blue showing the lunar tide, and the light blue, the more blue light blue showing the solar tide. So when we're in the new moon or the full moon phase, we have that alignment where the solar tide and the lunar tide add together and combine to be a super high tide. That's called spring tides. Neap tide is where we have the third quarter moon or the first quarter moon alignment. So they're out of alignment with each other. So the lunar tide is here in alignment with the moon. The solar tide is here in alignment with the sun. So they cancel each other out. We do not have that addition of tide. We are going to have a less extreme tide changes during the neap tide phase. So here is the map of moon phases for most of the month of February. This is for this year, 2021, in Huntington Beach, where I live. So you'll notice here we have our tide changes. So the high tides are marked by the blue dot, the low tides are marked by the tealish green dot. So you'll notice that where we have the most extreme tidal changes is around here, February 9th, 10th, 11th. We have very high tides, very low tides, and that corresponds with the new moon phase. Now, where we have the least amount of difference in high tide and low tide is going to be February 4th, 5th, 3rd maybe, and then again 17, 18, 19. And this is where we have high tide and low tide that are pretty close together, much less extreme differences than we saw here. And that is due to the fact that that is the time of the quarter moons. So you'll notice as the tide is changing, it aligns perfectly with the moon phase because, of course, the changes in tides are caused by that moon phase being in alignment or not with the sun. So we have the spring tides at the new moon, and then again at the full moon, which isn't on this chart, whenever the sun and the moon are in alignment. So they mentioned this at the end of the end of the clip of the video that I showed you, but the tidal effect is actually slowing down Earth's rotation. So there's a lot of friction, the tidal bulge against the ocean floor. It's actually causing the rotation of Earth to slow down. So every century, the Earth slows by about 0.0023 seconds in daily rotation. So 900 million years ago, the Earth's day was actually 18 hours long. So it only took 18 hours for the Earth to rotate around its axis. But it's been slowing down since forever, since we've had the moon there. So it's actually the gravitational pull on the moon that is causing the bulges that then cause the Earth to slow down. And the gravitational pull on the moon is also actually pulling the moon forward in its orbit. So the orbit of the moon around the Earth is also getting larger. So the Earth is slowing down, its rotation is slowing, and the orbit of the moon around the Earth is getting larger. Very, very slow changes, but these changes are occurring because of this relationship. Does the moon have tides? So we know that the tides on Earth are caused by this gravitational pull, an attraction between the Earth and the moon. So does the moon have tides? Yes, same thing. But the moon does not have oceans. So the Earth's gravitational force that's exerted on the moon does cause a tidal effect, causes very, very, very slight motion in the rock on the moon. But the gravitational force of the Earth on the moon, combined with the friction caused by this flexing of the rock, is actually slowing the rotation of the moon. So the reason we always see the same side of the moon is the moon's high tide always faces us. So the same way that our ocean bulges and the high tide bulge always is facing in alignment with the moon's high tide is always facing us. So this is considered to be a tidally locked system. So if you have ever heard tidally locked, that is just like the Earth and the moon, where the high tides caused by each other are always going to be in alignment together. So we always see the same side of the moon. We always see the high tide side of the moon.